Hi everyone, I'm going to do a demo and we'll see how well this works. I'm feeling this is the classroom we're normally in, so it's kind of hard for me being here to tell you the truth. But a lot of students said they liked the demos and we'll pretend like we're in class together. So what I've got here are solutions of sodium, potassium, copper, and boron. It's sodium chloride, potassium chloride, copper chloride, and then boron is boric acid. And it doesn't actually matter what the solutions are. Once this goes, if you've watched the previous, there's going to be 2 demos here. Once it's in the heated up, it's actually the gas phase atoms that are involved, and that's what we're going to see. So I'm going to see whether I can do this or not, and then I'll have to go turn off the light. So just going to pour in the solutions. Probably should have done that before I started it. And what we're interested in is the electronic states of these atoms. Where are the electrons in orbitals on these atoms? And how do those, this one's a little tight, hold on. Very high production qualities here. And so how do those electrons interact with light and energy? So I'm just putting these in these little dishes, and then I'm going to light them on fire. And it's kind of fun. Hopefully it'll show up. If it doesn't show up, I won't post it. How's that? All right, so I'm just going to light them. I usually do tell the class when I do this. If any of you become high school chemistry teachers, make sure that you talk to me before you do this. I'm on a chemistry education listserv. This is the #1 where accidents happen and people are hurt. So the most important thing if you do this demo is these are solutions in methanol. The reason we use methanol is it does not emit, when it burns, it's not emitting light that we can see, so it doesn't interfere. But the problem with that is you can't see whether it's on fire or not. And so the way to do this demo, if you ever do it, is you never bring the container of methanol with you to the classroom so that you're not tempted to do something stupid. So what's happened before is people won't think it's on fire, and then they'll add more in, and it blows up in their hands and has injured students in high schools sitting in the front row. So I'm going to light these on fire, if I can. And you'll see not a whole lot at first. And even the copper one, you can't even tell it's on fire. Now I'm going to go turn off the lights. I'll be right back. I really should have someone come with me, but I'm not doing that because I'm not wanting to expose anyone. So, isn't that cool? Now imagine you were here in class, and the idea here is we're seeing different colors for the different elements. I'm not sure if, right now I think we're seeing a lot of orange on ones that shouldn't really be orange, like the potassium one. And I don't know if that was, maybe I didn't get the dish as clean as I could. And the boron color is not really showing. I don't know if my phone is, the boron just looks white, doesn't it? It's actually really green. Maybe you can see green tips on it. So I don't know that this is going to work as well as I would like because the colors just aren't showing up on the phone very well. Can you see that the potassium's a little bit different color than the sodium? Not really, darn it. Oh well, I did my best. If you were here, the boron one is unbelievable green color. And I don't know, it just, because of I think the cameras just pick up and adjust their colors based on that. And so, because the boron looks so much different to the camera than the other ones, it's just kind of all whited out. All right, but anyway, here's the idea, the chemistry we're learning. These different elements, oh, it's getting toasty. These different elements are emitting different colors of light when we're burning them in this flame. And we can use those different colors of light to actually identify the element. There's instruments where you can do that. Maybe you can see the different colors. A little bit. That's not great, man. It looks a lot, I'm looking in person, of course, and on my phone, and the colors are just kind of washed out on the phone. Let's see if this, no, it's not good. Oh well, I did my best. Maybe you can see that the boron looks a little different from that angle, though. Anyway, so we have instruments. You know, this is just with your eye identifying the different colors. Maybe you can see a little bit of the purple in the potassium now. But we have instruments that can identify exactly what wavelength of light that is. And in fact, there are instruments where you can inject a whole bunch of metals and identify all the metals all at once based on the color of light. It looks like copper burnt out now. Anyway, that's it. What we're going to do, maybe the potassium's starting to, it's just, I think it's so bright, all I'm seeing are white flickering flames on my phone and not really getting the difference. Well, now you can see, I think sodium looks orange. Can you see a little purple in the potassium maybe? Oh, maybe the boron's starting to look a little green on the phone. Oh, bye-bye potassium. Well, you can at least tell the difference between sodium and boron, right? Sodium's a typical reddish-orange color. It's not anywhere near what it looks like in person, unfortunately. And the boron is a turquoise green, greenish blue. I think you need a different kind of camera to be able to pick up the true colors. I'm just seeing a lot of white. All right, well, I'll post this and then we'll talk about the different energy levels that are involved and how you can identify metals based on this interaction between electromagnetic radiation and the atomic orbitals in atoms. I'm just going to let it burn out, see if the boron will, kind of see a little green there. Nothing like in person, though, I hate to say. All right, well, if we're in person next semester, I'll do this one over in person just so you can see it because it's pretty cool. All right, thanks everyone.